I acknowledge the elders, the families and descendants of the Wurundjeri people who have been custodians of these lands for many generations. I acknowledge the land in which we meet today was the place of age-old ceremonies of celebration, of initiation and renewal, and that the local Aboriginal peoples have had and continue to have a unique role in the life of this university. So tonight is a special night for our speaker, Professor Mark Wilson, in terms of his role at the University of Melbourne. It is his inaugural professorial address, which is a tradition that we have for new professors at the university. Mark is a Professor of Assessment here in the Graduate School and based in the Assessment Research Centre. He's also a Professor of Education at the University of California, Berkeley. And he spends 3/4 of his time there and 1/4 of his time here. But he's not new to the university. He completed his Bachelor of Science with honours in mathematics here at the University of Melbourne in 1975 before going on to complete both a Diploma and Master of Education. Soon after his Masters, Mark moved to the United States where he completed his PhD at the University of Chicago on educational measurement and educational statistics. So with this interest in measurement and applied statistics, Mark's work spans a range of measurement and assessment issues, from the development of new statistical models for analysing measurement data to the development of new assessments in subject matter areas such as science education. And he's also interested in patient-reported outcomes and child development and policy issues in the use of assessment data in accountability systems. He is an internationally recognised specialist in psychometrics and education assessment. He's President of the National Council for Measurement in Education in the United States and a past President of the International Psychometric Society. Naturally, he's widely published and was also the founding editor of the journal Measurement, Interdisciplinary Research and Perspective. So tonight, Mark is going to explore that relationship between large-scale and classroom assessments. That's clearly a topic that's of interest to everybody here, including the benefits and the problems. I've asked my colleague, Emeritus Professor Barry McGaw, Director of the Assessment Research Centre, to move the vote of thanks at the conclusion. So will you now please join me in welcoming Mark to the front.
Well, thank you, Field, for that kind introduction. And thank you for being so enthusiastic and supportive in bringing me here back to Melbourne. I really appreciate it. So I'm going to talk about a topic that I've spent probably the last 30 years embroiled in, the relationship between classroom assessment and large-scale assessment. I'm going to mainly base my comments on my experience in the US, because that's where I've been doing it, but I think it has some relevance for here too. Here's something that I found recently, reaction to an article about the NAPLAN release, and I thought I picked it out, not because I think it's particularly accurate, but because I think it reflects a certain view about the relationship between large-scale assessment. I won't read it all, but for instance, all the NAPLAN results show is our teachers are failing our students. Whether you agree with that or not, and I think it's actually inaccurate regarding what actually came out, but what the position is that whatever the test tests, that's what teachers should do. That's what they should bring about. That's what's behind this sort of thinking. And this is from Nicole, who will remain anonymous, but I must assure you that it's true for many, many people in our society, and many, many policymakers in particular take this view. And they'll tell you it's the hard-nosed view. It's the view that goes with big data. You know, today, metrics in business, big data are all about this sort of stuff. So I'm going to talk a little bit, first of all, about what I see as the current problem between that, classroom assessment and large-scale assessment, and then I'm going to spend some time on talking about how I might see we would like to resolve this problem. There's a nice blank down the bottom because I'm going to explore that later on. So starting off, a couple of definitions. I'm an academic, I like to have definitions, and I like to know what we're talking about. I want to define, first of all, formative assessment, and I'm going to, of course, contrast this with summative assessment. This is a definition that really derives from work by my colleague Paul Black and Dylan William at King's College. And what they're saying here is that what is most important about formative assessment is its use as feedback by teachers and their students in assessing themselves and each other to modify the teaching and learning activities in which they are engaged. So this is where we get information to make a difference. We're going to directly make a difference. We've got a decision to make, many decisions perhaps. Contrast that with summative assessment, and we see the difference here. It's being used to provide a summary of what a student knows, understands or can do, but not necessarily to help by providing feedback. It's that snapshot that we want. We want to see how did they do at the end of something. And you can hear that in the words formative and summative. And this is really the main difference between classroom and large-scale assessment, although it's not completely. Because in fact, it may be possible to use some large-scale assessments to give certain types of feedback. After all, it would be interesting perhaps to know how the kids went last year in science or English or whatever. For the teachers the next year, that would be seen as feedback then. And equally, in terms of summative assessment, some classroom assessment is going to be summative because we want to know how they did in the unit, we want to know how they did in the semester, we want to know how they did in the year, and we want to take a snapshot of that. So this distinction is about usage, but it does in fact predominantly characterise large scale, that it's summative, and classroom, that it's formative. Now, what matters most? Well, there's a little bit up there as the heading on these. Classroom assessment. Now there's a lot of classic work on this. I'm just going to mention this meta-analysis by Black and William, 1998. They found that formative assessments gave standardised effect size of 0.4 and 0.7. Does that sound like a lot? Hell, it is. It's a real lot. It's much bigger than almost anything else that we do in education. There aren't many other effect sizes as big as that, and there have been many other meta-analyses before and since, even some done by people in this room. Large-scale assessment, what do we know about that? Well, what I see when I watch what happens, say, with the NCLB, No Child Left Behind assessments that go on in the US, is that yes, indeed, when they bring in a new large-scale test, the students improve, but they then come to a new equilibrium pretty quickly. There's sort of an increase and then a flatten. Now, when you actually go and check whether they're the right results or not, you find that there's some questions. So in the US, they not only have the NCLB, which is the large-scale population-based census tests in every state, they have something called NAEP, National Assessment of Educational Progress, and it's a sample. It goes in and just takes a sample of kids from some classes within some schools. So there's no preparation for that, there's no special training, there's no getting ready for it. For the state tests, there's an awful lot of getting ready for it. And you know what happens? It just does not, those gains that you see on those state tests are not reflected in NAEP. There are some modest gains over time. Also some declines, unfortunately, in NAEP. But there is not consistency. So what you see happening is an enormous amount of effort, an enormous amount of money. Obama recently, or a couple of years ago, put $450 million into just this sort of assessment. But when we check on it, it doesn't really seem to make much difference. So, it seems to me the issues are, we need to balance up what are these good effects of the summative tests on curriculum instruction versus the bad effects. And let's have a look at what some of those are. First of all, the good effects. I'm not a naysayer about tests. I love tests. No, I don't really. But it's good to have information that's reliable and comparable. And let's think about what it's good for. I cut these up into two sets of things, by the way. One of which is the thing that really the science is about, information, but the other thing is something else. I call this signification. This is what messages do we send with our tests? And there's a couple of ways that we send messages. We send messages to teachers so they know what the standards are that they should be teaching. Because although teachers are professionals, they don't read those books of standards, they don't look that up. What they do is they go and look at the test and see what's on the test. And if it's on the test, then they start to teach it. Not only that, but it also gives them concrete examples through items and maybe other materials of what it is that should be. It's not just an idea that's in a standard, there's an actual item there that they can look at. They can see, well, this is how the kid would do it, and that's how they figure out how to use them. These are important things. If we want to drive what is being done in our schools using things like standards documents or other sorts of documents, then this is extremely important, and tests actually are the things that make it happen. Information. Now, of course, this is the thing that the psychometricians, the educational measurement people, that's the thing they're interested in. As you can see, I think it's actually the second most important in this case. It gives teachers very coarse feedback on their students' performance. And that can be useful sometimes. I would say that if you're a decent teacher, you would know as much as you're going to get out of a test within a week or two of being interactive with a student. But it may be useful. It gives principals and the educational administrators feedback on the performance of students in their schools and districts. And here, of course, this is something that they can't get directly. They can't go into the class and see what's going on. So they need these sort of statistics. Parents get, again, that very coarse feedback, but it may be appropriate. I don't know that most parents really can deal with anything below the level of, say, science, maths, English. They probably can't go, they might help out with homework, but getting information about other things I don't know is very, very useful to them. So these are some things that I would say are the good effects. Some people in the room may not like standards, say, or things like that, and they would say they were bad effects, but I think they're good effects. Now let's look at the bad effects. Again, I've split it up into signification and information. First of all, in signification, what happens here is that whenever you create a set of standards, they're very aspirational. People sit around in committees, they have high ideals, and who would not agree with high ideals? But what you find is that when they put those sets of standards out, they find that they cannot be tested because the test has to occur in real life, in real classrooms, in an hour or whatever that amount of time is. And certain things can't be tested. So some standards actually just get left out. The second thing that happens is it's not just whether the standard gets left out or not, but it's what the standard really represents. So any given standard will be quite complex and have depth in terms of how you might test it and what it might mean that you get a certain score on it. And what you will find is that there can be narrowing of what the standard is because of the very specific restrictions on those items. So these are some bad things that happen due to signification. That is, there's a narrowing down of what we ought to be teaching depending on what we can measure easily and at not too great a cost of time and money in the particular testing window that you have. In terms of information, we can see sometimes people try and use standardised tests for diagnostic feedback. I think that's usually bunkum. One way you can tell it's bunkum, if they don't tell you the standard error, then you know it's not a good thing that you're using that information, because that's what tells you how variable the information is. The information is more relevant to principals and other educational administrators, but it may not be the right information for decision making. Again, then this has to do, of course, with the narrowing that's going on up here. If the principals are using that information, then they may be misusing what they really need to know. Now, let's think about how we can talk about the relationship amongst these things. I've got a diagram here. It's a very classic diagram. Some people call it the CIA diagram. It's just sort of a way to describe when we think about what happens in curriculum. This is sort of curriculum statements as in standards. This is instruction. This is what teachers do in the classrooms. And this is assessment, how they assess whether they got what they wanted. And of course, it's sort of seen as going in this direction here, and that the assessment, of course, the results feedback to tell us, did we actually achieve the curriculum gains or did we not, and what should we do? This is a very standard sort of triangle of learning, it's called. However, when we put someone in one of these large-scale testing situations, something slightly different happens. And this has been labelled the vicious triangle by my colleague Paul Black. And what he sees happening is that, sure, the curriculum drives the instruction, but equally the very tight control of the curriculum on the assessment also drives the instruction. And teachers get in this point of sort of at this pincer point here between these two forces. I've got some results here. These are a few years old now. They're back from the first few years of No Child Left Behind in the US. We see what were some results of teachers reporting how they felt and how they responded to that NCLB, that state testing going on. Some thought it was somewhat useful. Most thought it was not at all. More thought it was not at all helpful. 40% thought it encouraged rote drill because, of course, you really want to get them to learn those particular things. It eliminates curriculum material not tested. A large group agree with that. And of course, that's that narrowing I was talking about. Does it encourage them to improve their teaching effectiveness? Well, 3% think it did. The 3% who like numbers, I think. No, I'm sure there's more than that. Is it an effective way to assess the quality of schools? Even fewer than 3% thought it was a good way to do that. What effect does it have on teachers? 69% say it contributes to teacher burnout. And what worries me is that this may be the better group of teachers who are being burned out here. So this is a very, very strong regime we've got going in this sort of testing. Now, there has been a glimmer of light on that just in the last few years by Obama, and he's put out some statements that there's too much testing and we better cut down on it and ensure that no child spends more than 2% of her classroom time taking these tests. And that sounds good. 2% doesn't sound like too much. But of course, the words are time taking the tests, and really it's not the time taking the test that's the bad thing here. It's how much time you spend drilling on the test. So he didn't mention that in there. And Mike Tucker, who's pretty much a supporter of his in most things, came out and had a very strong statement about the problem is that what's happened is you've got a lot of cheap, low-quality tests going out into schools, and what he thinks is needed is much higher quality tests. And I agree with him. I'm not against the idea that teachers should get a help in understanding what their kids should be doing. The principals should know that we should be giving materials to teachers to help them use their tests in their classes. But how do you go about it? I think how you get these much higher quality tests is not at all clear, I think. And that's where I'm interested in coming in. So Paul and I put together this nifty diagram to fix up that vicious triangle. I don't know whether it's true or not, but we do have this idea that there needs to be something in the middle here that's driving it all. There needs to be theories of learning. Ones we believe, there needs to be evidence for them. And learning progressions is sort of the title of the idea that at least I've latched onto for this. There's a bunch of definitions around. You could think of the learning progression, well, that's just the series of topics in the textbook. Well, no, that's the structure of the discipline, of the ideas. The learning progression is the progression in the kids' ideas and what's going through their heads. So it's a progression of psychological states, essentially. Now, we might express achievement that we're interested in, so the psychological states will be expressed in terms of achievement, and they will be part of that set of ideas in the textbook, but they're not the same thing. One issue that often comes up when we discuss these learning progressions is people say, well, gee, not everyone learns the same way. And that is certainly true. And when we write these learning progressions, we need to write them in a way that acknowledges that possibility. Nevertheless, over a population of students, there are going to be some generalities. And it's really good as a teacher to know about those generalities. It's important to know about exceptions too, of course. Now, here's my image of a learning progression. It's a nice, vague thing. This person down here, this is actually a science educator. His name is Joe. He's a colleague of mine. And he has these thoughts about how you start off learning just very simple little things and it becomes more complicated and more complicated and more complicated and very, very complicated by the time you get up to top here. And this, I think, is a very good way of thinking about learning because it's like that. It's interconnected, it's multidimensional, it's complex. It's a little tough, though, when you're going to try and build assessment systems for that. I'm going to come back to this. Just keep that image there in your mind. I'm going to come back to it and talk about it a little bit, but I'm going to just talk about some other things in the meantime. So now I'm going to start talking about my strategy for resolving this problem. And first of all, I'm going to talk about something I call the Bear Assessment System. And it's really, we're just going to take one construct at a time. So it's going to be simpler than what's going on in that diagram, but I will come back to it. The Bear Assessment System is a way of developing assessments. And it's a sort of an interactive discipline of observation. First of all, you postulate something you want to measure, and we call that a construct. We build a map of it. We use that to tell us what our tasks should do. We give tasks to students and they respond to them. And then we value their responses through something called an outcome space, where higher scores will mean higher on the construct. After that, we have a lot of complicated data at this point, and we need a way to analyse it. And that's where statistics comes in, and we build these statistical models that relate to an empirical version of this construct map. It's going to be one dimension at a time, so we're going to keep it pretty simple. We know there's going to be lots and lots of these simple things that are being developed as kids get more and more sophisticated in their understanding. I'm going to take you through an example of that. This is an example put together by some colleagues of mine, Rich Lehrer and Leona Schauble at Vanderbilt University. They are interested in thinking about how teachers learn to be teachers, and they see that the system of assessment is intimately connected with the professional development of the teachers. Of course, it's intimately connected to the development of the students as well, but knowing about a system of assessment is what's needed by the teachers, and this is played out in the classroom learning. And again, we put this learning progression in the middle here to show that it's all interconnected through that. Now, here's how they see teaching of statistics in the middle school in the US. They call it instruction in pieces, and what they look at textbooks, what they find out is that kids don't do various things, and it's called statistics or data analysis or something like that. They learn that statistics is something that you do to data. You get sets of data, you calculate the mean, median, and mode. That's what you do to it. There are certain ways that we learn we must display data. We take data simply as something that comes on the page or perhaps on the screen to us. It's given to us. They have some reference to chance and maybe inference. Well, really, this is what we really want to know. We want to know, how do we use data to make decisions? That's the whole point of statistics. And they don't see any connection amongst these things. That's the criticism that you want to create a construct map out of this. You want to say, well, there's all this stuff lying around. How do we connect it all up together? And here's their picture of how they can put it together. This is a picture here of some kids out in, actually it was in the sort of the backyard of their school, which had been flooded, and there were big pools of fresh water there, and things were growing in them. And so they took the kids out there and they had them collecting the different animals and plants that were in that area. And they asked them to pose questions about that. Now, first of all, you see that they're escaping from this idea that data is just stuff that comes on the page to you. It's not just in the textbook. It's not just motivated by the fact that you're told by your teacher to do it. You're motivated by what's really happening there in front of you. They help them to develop questions about that. Why do certain species grow here? Why are they not growing over there? Why is it so bare there? Why is there nothing just there? They develop these questions. They have to think about generating and selecting attributes. They have to measure things. Then they start to build up data because they structure those measures and they represent them, and that's what data is for them. And then, of course, they have to describe it, and this is where the statistics comes in. Then, and this is the thing they do that really blew my mind when they first started doing it, they say, well, good, we're now going to ask the kids how they think those data arose. They're going to say, well, there was a probabilistic mechanism by which those plants grew there and those plants grew here, and there was sometimes a mixture over here. And I'll show you a picture later of what the kids used to do that. So they actually model the charts, and this drives them back to pose more questions. This cycle is what they see as driving their curriculum, and it's a mixed curriculum. It's in math, but it's using science, mainly in this case biological science, as a way to drive it. Now, when you come to think about this as assessment, what you start to realise is that each of these attributes becomes one of the things we need to know about. We need to track kids as they're making progress on this. And in fact, and I'm skipping ahead in the whole process, when we did this, eventually after about 2 or 3 years, we did come up with a list of the dimensions on which we felt that we were interested in knowing how the students progressed. There are 7 of them. I'm not going to try and talk about all of them today. I'm actually going to talk about this one here, conceptions of statistics, which was characterising distributions. And that was this one down here about what do we do when we get the data and how do we describe it. And we built a construct map for that one. As I mentioned, we take them one dimension at a time. There's a lot of effort goes into distinguishing what's multidimensional and what isn't. Everything's multidimensional. We know that. But what's sufficiently unidimensional that we can think about it as one thing at a time? That's the discipline we need to work on. And it takes quite a while, and a lot of effort in order to go from your theory about what you want to what you actually see kids do, and then go to teachers and say, well, what would be useful to you? So there is sort of a triangle of information here. This is one here, it's a rather simple one. We always write them with the low kids at the bottom, the kids who are less sophisticated and what they're doing. Describe qualities of a distribution in an informal way. Calculate statistics, middle school, mean, median, mode. What's the classic anyway? Consider statistics as measures of qualities of a sample distribution. So this is going beyond just saying that's the mean or that's the median, but what does the distribution look like? Underlying this, of course, is conceptions of variability, which are extremely important in biology. So the biological impetus is coming into this use in data. And at the top there of this one, investigate and anticipate qualities of a sampling distribution. Any of you have tried to teach someone about a sampling distribution? That is the distribution of the measures of the sample. You'll know that's a very interesting and hard thing to get through. You'll see a little bit of it later though. So that's a little bit of summary of the story of how you build a construct map. I've skipped over 3 years of work in that. What you want to do then, given you've got your construct, is then design tasks. Now they need to satisfy two things. One thing is they need to be interesting to the students, and they need to inform us as teachers and observers of what the students are thinking about and how it relates back to those constructs. So here's some pictures of that. And there was one of these, a whole story for every one of those dimensions. But this is the one about measurement initially. And we were working in the area of biology, but the problem is if you try and get at what's the reasons for variation in biology in middle school, you start to talk about DNA and you're sort of talking about stuff that kids really have no relationship to. So in order to unwrap that, their idea was we'll talk about measurement of other sorts of things, but complicated things that aren't too easy. So one was that students in groups had to measure the wingspan of their teachers. And here you go, this is a teacher here, and there they are, there's their arm stretched out, and they were going to measure it across there, and they're using little rulers here, and I'll come back to that. The other one they do is they do this sort of fake trigonometry, where you are trying to measure the height of a tree or a flagpole, and you use these little tools here, and you point at the top, and you measure the distance from you to the tree, and then there's a little protractor thing on that does the trigonometry for you so you know how high it is. But of course, you can imagine that there's quite a bit of error in there, so there's a lot of variability in what the kids learn. That, by the way, is the Richard error right there. And so, what do we do with that? Well, some of the things we do, we get the kids to work in groups, and they come up with graphs of their results, and some graphs are good and some graphs are terrible, and some graphs have very, very interesting things on them that no one would have expected. I won't go into the details of that, but we have a data displays construct that describes all of those. We get them to look at issues of variability. They start to learn about variability being important, partly from just thinking about what goes into these graphs. There's variability in every one of them. And they tote up these sort of descriptions of how much variability is there. That we're trying to get this idea of precision or standard error and so on. And this is a nice one. At one certain point, you move them over from doing it all by hand, and you give them a little tool that allows them to actually do data analysis on a screen in front of them. But you don't do it until they really have got the idea. But here's some nice results that some kids put together. And this is actually that wingspan data. And they've got these are pairs of students measuring the wingspan of their teacher. It's the same teacher, both times. And here they're doing it with meter rulers. That's this one. And here they're doing it with foot rulers, like 30 centimetres. And you start to notice that there's something going on about this. Interestingly enough, if all you cared about was the mean, then the mean is almost exactly the same with both. So you wouldn't have noticed that there's something else going on here in terms of variability. And so they're using this sort of insight coming out of the students' own work to build up in their ideas something very crucially important about statistics. Here's a picture of these, what they first did about this probabilistic modeling. They would have the kids postulate what would make the variations. If it's this wingspan, Well, is the teacher's wobbling their hands? Is the teacher really stretching out? Is the kid doing the measuring, holding it straight? And they would work up these little probabilistic models, and they'd use spinners to simulate data coming out of that. Now again, after a while, this becomes pretty tedious, especially if you want to do 100 replications and see what happens. So again, they have a piece of software that allows the kids, here's the spinner here, that allows them to, and they can spin it 1,000 times on the computer and get the results. But they do come up with some interesting things. Here's something that one kid wrote as his response to seeing this happen. And if you look at what's happening, about what happens as they spin it 10 times, 100, 1,000 times, and you look at how the results go, you will notice that this kid has discovered the sampling distribution of the mean. Something I will tell you, one of the fascinating things about this was that the people who were working on it were the students who did teaching the grad students in introductory PhD level education, teaching statistics to them. And the problems that these grade 5 and 6 kids were having were exactly the same ones that the grad students were having in their introduction to the PhD statistics. So, which says something that not much happens in between middle school and grad school in terms of learning statistics, at least for the ones that come to Berkeley. So, talked about design of tasks. So a little bit about the outcome space. As I mentioned here, here's this one of these 7 dimensions, the conception of statistics. I'm going to unpack this one here just very quickly, just to give you a glimpse of the sort of complexity that we actually observe. This is a nice, it's just 4 things in a row. It's a nice simple dimension. Well, it turns out that that third one, the one that I had outlined in blue here, actually has all these different ways of observing it. These ones, by the way, are not as ordered. They do go from sort of simpler to sort of more complicated, but there's no simple order here. So this is the thing called the outcome space, where we actually interpret what the kid's doing, and we use that as part of our model. Go on and talk about this stage here. What happens is we go and collect a bunch of data about this. We want to put it through a statistical model and understand what it does, and we end up writing creating maps of the student progress. And this here is a picture of that. Again, it's going from low down the bottom here to high here. These are little things called logits, which are the units we use. And each X here is several students, and this is a histogram of their progress from very low. Hope I'm not standing in you guys. Well, I'll try and get over here. From very low to very high. As you can see, there's a wide range of variation here. And what we're seeing as we go along here is that, remember those levels that I showed before? And I'll just go back and remind you, there were these 4 levels. 1, 2, 3, 4. Well, here, this is level 1 items, these are level 2 items, these are level 3 items, and these are level 4 items. And when we wrote it out like this and had another look at our test, we found there was a group of items that didn't fit our ideas at all. When we wrote them, we thought they did, but what the students were telling us was that they didn't. This was really just kids who could, and items that asked kids to just say something sensible. Now, we didn't leave them out because we think it's a good idea to encourage people who don't quite know the answer to still say something sensible. But indeed, we discovered a lower level than we'd expected. What we were sort of hoping was that there might be this very nice step range from going up our levels. As it turns out, as you can see what's going on here, items tend to spread out a bit more than you would like them to in an ideal situation. And of course, this is often the case in testing, it was hard to test that highest level. We did have at least one item that came up there, but indeed we learnt that we had to go and write some more. So this is a picture of a right map that what this allows us to do is to say, well, we can now characterise what these kids in here are doing as this level 2 type of work. These kids here, fewer of them, they're doing level 3, and that one kid there just made it into level 4. That was probably the kid who wrote that thing there, I think, perhaps, I don't know. So that's a picture of the procedure we go through. And as I wrote it down, it's a cycle. You end up doing this multiple times. Unfortunately, we could only get to teach this stuff once a year with these kids because they had a lot of other things they had to learn. So there was but the good thing was that there was a year in between for us to do a lot of analysis and data crunching that would help us understand what had happened. But we took 3 or 4 years to actually work through from our initial idea of what might happen to what really happened in the classroom with a very exciting and innovative instructional program as well. This is the sort of thing that I do most of my time. I work with creative curriculum developers, creative teachers, teachers of teachers, and create what I see as diagnostic outcomes for teachers to use in their classrooms. Maps like this, descriptions like this. This is something I think can be very, very helpful to teachers. And really I've spent most of the last 20 years doing this stuff. But as I pointed out at the beginning of the talk, I found that a lot of my good work gets crushed when we go out into classrooms because they've got to practice for the test. They can't do the test because they've got to practice for the test. That's what happens in my classroom. So that's why I've become interested and am getting embroiled in large-scale testing as well. So that brings me to my second part, a two-part strategy for resolving the problem. Using formative assessments to help design large-scale assessments. What I want to do is to stop there being this situation where the teachers are in a pincer between what they think they should do and what the test is making them do, and make them do the right thing by giving a test that's good in their classroom and that relates to the test that's going to be given in the large-scale test. So, answer part one. Well, now I want you to go back and remember that diagram about Joe, the science materials developer, and his idea of what the learning progression was. And I want to suggest that one way we can think of what we're doing in a test is we're creating sort of the latitude and longitude of these sorts of diagrams. They're not going to have the complexity of the interrelationships that might really be there, but nor do latitude and longitude. And if you're navigating your way around a complicated thing like an ocean or even a bay, it's useful to know these things. They don't ask too much of them. We don't ask the test to do everything. They can't, but they can give us some basic information. So here's an image of that idea that we might have a dimension. I've just got a diagram here with 4 dimensions. I could have put 7 as they were for the example I had, but 4 was enough for this case. What we can think about is how to make a summative test out of that. Well, it turns out if you've done that hard work of creating the classroom assessments, then it's not too hard, because what you really want to do is to project that information from your 4 dimensions onto a summative test. And you can do a lot of things with that if you just do it properly as a technical task. It's one that measurement experts know how to do. But what you get out of that is a derived measure. It's based on the sampling designs of the levels. You can control the reliability by how heavily you sample the items. You can even develop a construct map, not quite the same one as the one that we talked about before. The construct map I was talking about before was one that's based directly on the learning theory. This is one that's based indirectly on that through the fact that we've sampled across all these items, and effectively you go backwards from the test to a description. For those of you who know something about PISA, you'll realise that this is what's called the described variable technique there. And they actually don't use like a technical solution like this to come up with theirs. They use a panel of experts, but that's effectively what they're doing when they do that. So you can also have things like construct maps. You can have a lot of success with this. The problem is, when you do it, it's not clear how you should choose those items. I mean, you could, if you wanted to be really probabilistic, you could just do random selection, but maybe there are smarter ways to do it. And in fact, that's what the second part of this answer is about. Because it turned out that when we went and looked very carefully at the 7 dimensions of our assessment system, and here are the 7 dimensions here going from low to high in each of the dimensions, that there were some interesting connections. The fact they're stacked like this means that there is, of course, a connection up each of these. But we also found that when we did what's called a process analysis of what students do when they answer those items, that for instance, if you wanted to succeed on this level 2 of this particular construct, and this is modelling variation, then you had to be also successful at the top level of theory of measurement. If you wanted to get to this level 3 of chance, above 2, not only did you have to be at level 2 of chance, but you had to be at level 3 of the ones we've been talking about, conceptions of statistics. That was true over here for this level 3 of inference, informal inference as well. There's something funny going on here where what effectively happens here is though you can measure these two things separately, they sort of blur together when you do the statistics of them and become one dimension. So it's an interesting thing going on there. We haven't entirely mastered what to do about that. But this is a much more interesting way of thinking about the relationships amongst these. Of course, you'll notice there is this sort of progression from left to right, and indeed the aim of the curriculum is to bring kids to this level of what they call informal inference, ready to go on to formal inference in say, a statistics class. Now, with this information as well, which by the way is informed quite strongly by the right maps, because the fact that, for instance, this one here is higher than any of those is something that's revealed to us by the statistical modelling, by the difficulty of, given by the difficulty of the items within those levels. What you can do is think about how you would go about sampling this to create not just a random sample, but an informed sample and an informative sample of items that will go on a standardised test. And the first thing you notice here, and we did write the diagram this way in order to show it up, is that this level here on COS, that one we've been looking at, is in fact crucial to quite a lot of other things. And so that would be one thing you would do. You would start off by saying, well, I better have some items from that one. You can make the same sort of logical connection as you go further out. For instance, you can see here that these two top levels of chance and modelling variation are crucial to making your way eventually to the top of the modelling inference up there. We can go down low and we can notice that knowing about these top levels of meta-representational competence and data design are equally crucial. And of course, knowing about the theory of measurement is important because that's really what we were using as our base. And this is where we want to get to. So what you find is if you can use these sorts of diagrams and the logic and the empirical information behind them to come up with a very intelligent set of items to go into your test. And they would in fact be a much more informative set of items. They might even be ones you could use diagnostically as opposed to the really non-diagnostic ones we have at the moment. So this is a sort of example of how you could go about doing that. Thus, one can see ways that these learning progressions can develop classroom assessments. We can use them also to develop large-scale assessments. And the important thing is that by doing it in a united way, we get this necessary coordination between the two. We can, in fact, have standardised tests that are not going to be so uninformative to teachers. They really will be useful. We need that, to design the outcome progression, that's the assessment in this case, to allow this to occur. And one way to do that is these construct maps using the Bear assessment system. There are other people who are doing similar things, and I'm not claiming this is the only way to do it, but it is in fact one way to do that. Now there's a bunch of challenges to do with this though. One thing is we need to develop learning progressions across important curricula. That's quite an important issue. We need to have what I think of these sort of political / curriculum debates about what's important. We can't just have the case that because someone put out a textbook, that's what becomes what gets taught. We have to really debate this. This is the thing I think will be good for us to do as an educational change maker. There's a lot of work to develop those assessments, and what happens is when you develop these assessments and you find out what the kids really think, you end up redeveloping the learning progression. So you end up going in this sort of cycle here for a while in order to do that. And that will lead us to rethinking blueprints for large-scale assessments. There's a lot of fun in this for those of us who like to do research. In terms of methodological issues, there's a lot of new sorts of things to measure. One other topic that I've been working on is building knowledge through social networks. There's very interesting sorts of things there. One thing about this is that we probably need to have more possibilities of getting multiple pieces of information out of single student activities. At the moment, each multiple choice item gives you one piece of information. What is needed is really more complex tasks, which give multiple sorts of information, and they will be across perhaps content and process. The good thing about technological developments is that if these kids are doing these on computers, there's all sorts of interesting information available to you beyond whether they got it right or wrong. There's curriculum and assessment issues. I think that if we work in this way, we can move beyond what I think of as the horse race nature of evaluations that get done, where we can actually, in a sense, think of curricula as hypotheses that we can test. Is this the good way or that the good way to test, to teach kids? And we can carry out investigative research on that basis. Thank you.
Well, in 1984, Mark came back from the University of Chicago with his doctorate, returned to the Australian Council for Education Research, and was gone within a year and a half, back to America, to Louisiana State University, a university that has a strong football team. And they kept him for only 6 months before he went to Berkeley, and he's been there ever since, as you heard from Field's introduction. And that move was America's gain, but Australia's loss. And the fact that this graduate school has brought him back here 1/3 of his time each year is at least our partial regain. And we're delighted, Mark, to have you back, and particularly in the Assessment Research Centre, to have you as a supervisor for some of the research higher degree students and as a colleague for the staff. And we've had a more detailed presentation of some of the key thinking in here in one of our research seminars. What I expected and what we got from Mark was that it would be thoughtful and innovative, because that's what's characterised his work. It's scholarly in the best traditions of that term. And there are some important lessons, as he pointed out, from the US. There are lots of things we don't need to learn from them because we never do things quite as badly as they do. Some of the best things they do, of course, we don't match, but on average, you wouldn't go to the US to learn things. You'd go to the... no child left behind. Every state had to introduce its own tests, and as Mark showed, all the states' tests showed growth in student performance, which wasn't matched in the measures obtained by the samples survey undertaken by the National Assessment in Educational Progress, NAEP. That led a physician who was monitoring these results across the states, in which he observed that every state was above average, to coin the phrase, the Woebegone Effect. Many of you will know Garrison Keillor, the radio broadcaster who talks about Lake Woebegone, the fictitious place where all the women are good looking, all the men are strong, and all the children are above average. Well, the Woebegone Effect is what was revealed in the state assessments in the US. Every state was above average, and he speculated about why. Well, maybe they taught to the test, maybe they obtained tests from test publishers who had generous norms that would be easy to exceed. If this is the average on the test norms that were provided, you could be above that average and so on. Now, we've not had that phenomenon, but we have had some interesting experiences in this country. The first state to introduce statewide census assessments of literacy and numeracy was New South Wales, and in 1989. And within less than a decade, every state except Western Australia had introduced them. And Western Australia resisted because they said we have more intelligent testing. We're testing just a sample of students because we want to know what's happening at the state level, and if we test only a sample, we can test more intelligently. So in literacy, they didn't test just reading and writing, they tested speaking and listening. And ACR, where I was at the time, Jeff Masters and others were doing the work, Margaret Forster, were working with the West Australians to develop these tests. But in the mid-90s, the then Federal Minister for Education, David Kemp, said to the West Australians, if you don't introduce full census assessments of literacy and numeracy in the way the other states are, we will withhold federal funds. And the West Australian Minister said, no, look, we'll keep doing this sample testing and we'll make tests available to teachers to use to map onto the state scale. Then parents will know where their kids stand in relation to the state assessment framework. But that didn't satisfy Kemp. He wanted every child tested so every parent would get a report from a common set of assessments. And so West Australia was forced to fall in line. So we lost some important things, actually, of the kind that Mark says are always lost whenever you decide you have to test everybody, because you can't test as intelligently or as comprehensively as you can with a sample. We do have sample-based assessments at the national level in the National Assessment Program, not the NAP-LAN part of it, but the other where we test just science, civics and citizenship and ICT literacy. Now, ACARA has proposed that group of tests be broadened to cover other curriculum areas just with a sample so we could monitor what's happening. The reaction from the states has been so far not to support that broadening on the grounds that the full curriculum hasn't yet been implemented. Now, it seemed to me that's entirely the wrong approach. You ought to know what your baseline is before you introduce something and not say, well, we won't test until we've introduced it. So we don't know what students know about history, really, in any systematic way across the country, yet we have a new history curriculum. So there are lessons we could learn about how to develop assessments in a much more intelligent way, I think, than we do at the moment, from the sorts of things Mark showed with that statistics assessments. The Academy of Social Sciences has engaged someone to write up a piece about the impact of social science research on policy and practice in Australia. And someone in the Academy nominated the Australian curriculum as an example of work impacted upon by social science research. And the person who's commissioned to write this rang me and said, could you tell me the single piece of research that's had the biggest impact on the Australian curriculum? I mean, that's a silly question, actually. You could say, well, there's the work on misconceptions in science, there's the work on the acquisition of phonemic awareness in young children as a prelude to phonics and the acquisition of reading skills for kids to whom this doesn't come quickly and naturally. But what I've come to think about, having talked to colleagues, is that the one piece of, the biggest piece of research that I think's influenced the way we think about curriculum is work on learning progressions. Illustrated really powerfully by Mark, but exemplified to some extent in the way we thought about each of the Australian curricula. What are the developmental progressions that we know about from research, or that we can speculate but we might need to articulate better with further measurement of the kind that Mark's been illustrating? I think the notion of learning progressions is an extremely powerful one, but articulated and developed in the way Mark has tonight is even richer and more powerful, and I think we are in his debt. Thank you, Mark.
Barry, thank you for your thoughtful and Barry-like reflections. Mark, thank you for your eloquent presentation, and at times challenging, and I did say at the beginning that there might be occasions where you might want to go back to the recorded lecture and just go over some things. Not you, Mark, but others in the audience. So, Mark, in a moment I'll present you with this small plaque that is a mark of the occasion, but before I do that I'll just make some other closing remarks and then I will do that. But it is a mark of, sorry about the word, but it's a symbol of the significance of the occasion. So just before I do that, I just want to say that in 2 weeks' time is our next Dean's lecture, and I will advertise that. It's Professor Linda Smith, who's out here from New Zealand for 6 weeks. She's Pro Vice-Chancellor of Māori and Professor of Education and Māori Development. Linda will be sharing her reflections on the Māori experience of Indigenous education reform and development. So if you're not on our mailing list, you could leave your names out here, and I can say that seats are filling fast. So I'd like to just conclude these formal proceedings and now invite you all to join us outside and to engage with Mark and others. And Mark, thank you again, and join me in showing your appreciation.